We are graphing sine and cosine part 2. We are still graphing the transformations of the sine and cosine function. This time the focus is going to be on B and C of that general form, okay? Those are the horizontal types of transformations. So like your horizontal stretches and shrinks and your horizontal translations, okay? In the foldable, when you first open it up, it talks about amplitude, okay? And then when we open it up again, it talks about vertical shift. Those are older concepts that we talked about last week. So real quick, just going over amplitude. Remember that that is the value of A, okay? The amplitude is always half the height of the graph. It is the distance from some midline to the top of your curve, okay? Amplitude is always positive though. One thing you need to make a note of, amplitude is always positive. So even if there is a negative A value, amplitude is still 2. It's just that the graph got reflected over the x-axis. So please make a note that your amplitude is always positive. Amplitude is always positive. That A value also affects, as we know, the vertical stretch and shrink. So if A is greater than 0, it's going to be stretched. And then if it's in between, if it's greater than 1, it's going to be stretched. But if it's in between 0 and 1, it's going to be shrunk. All right. And then, of course, if it's negative, it's reflected over the x-axis. That value affects which coordinate when you're looking at a graph. It affects your y's. And so as we talked about last week, your x's are your angles, your big 5 of 0, pi over 2, pi, 3 pi over 2, and 2 pi. Your y's are the sine, in this particular case, of each of those angles, which is 0, 1, 0, -1, and 0. So for example 1, we're not going to actually graph this all the way out. We're just going to create the table. How would I apply the 3 to my table? I multiply that 3 by the y value. So then it would be 3. It would be 0, then 3, 0, -3, and 0. So my graph would be stretched, going up to 3, then going down to -3. Up to 3, down to 0, -3, 0. Roughly. Like so. This -1/2. How do I apply that -1/2? What would I need to do? Multiply all the y values. Now, if you multiply by the actual negative, it takes care of the flipping as well at the same time. So then that would be 0, -1/2, 0, +1/2, and then 0. So then again, like I said, it will take care of the flipping for you if you apply the negative when you're multiplying. However, the amplitude of the graph, for example, 2 would just be a +1/2. Amplitude is always positive. Okay. D, that affects your vertical translation, okay? Depending on the value D, your graph's either going to be shifted up or down. If it is greater than 0, that means it's going to go up. Less than 0 is going to go down. Again, that affects my y values. My x's don't change. So here, when I had sine +3, as you can see in the graph, literally every point went up 3 units. So that meant that I had to add 3 to all of my y values. Okay. When I look at this one was a combined one. Not only did it stretch by 3, but then it moved down by 4. Always apply your transformations following rules of order of operations. You do your multiplication before you ever do your addition and subtraction. So you apply the stretch first, then you shift it down 4. So that means that you would multiply all of your y's by 3, then subtract them by 4 to get your new graph. For example, 4. Okay. Shoes are squeaky. So for example, 5, what would happen to all of my y values? Then we get subtracted by 2, so that's 0, 1, 0, -1, 0. I would minus 2 from every single one, so I would get -2, -1, -2, -3, -2. And literally that would take every point down 2 units. What about example 6 though? What would happen to the y values in example 6? I have to flip it. So that means I will multiply all my y values by what? A -1, then add 3. The -1 will reflect it over the x-axis. The +3 will shift it up. So then my new coordinates, or my new y coordinates will be 3, +2, 3, +4, and 3. The x values don't change, so I'm still at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And of course, I could always repeat the pattern for -2 pi to 0, but we're really only concerned about one cycle right now. But today's focus is about B and C, okay? So that's what we're spending the majority of our time on. We already reviewed what happens to our y values. Now we need to be more concerned about what happens to our x values, because these are a little bit different. First off, the period. I explained it a little bit last week, but in a full actual mathematical definition, the period of a trigonometric function is the length of one full cycle of the graph. Essentially, like I said before, where the graph repeats itself, okay? The length, the horizontal length before the graph starts to repeat itself. That is considered a cycle, one full cycle. For sine x, the period is 2 pi, as we discussed when we talked about the graph of sine. However, not every sine graph will be 2 pi. To find the period, you'll need to apply the formula 2 pi over the absolute value of b. That is important. B does not tell you the period. You use the value of b to find the period, okay? You take the absolute value of it and then do 2 pi over that value. The reason why you need to do the absolute value is because if there was a negative on the inside, the negative reflects it over the y-axis, but you just need the positive value to determine what the period is. So here, the value of b is 3. So my new period is now 2 pi over 3, which means the graph will complete one full cycle between 0 and 2 pi over 3, as you guys should be able to see in this picture. Not only does it have a period of 2 pi over 3, but it's also been what? Vertically stretched by a factor of 2. Okay? But that 2 affects your y's, the 3 affects your x's. Okay? So in example 8, it says find the period of 3 sine 1/2 x and then sketch it. Well, in order to find the period, I need to do 2 pi over the absolute value of b. Well, the absolute value of 1/2 is just 1/2. I have a fraction within a fraction, so I have to what? So then I am going to keep change flip, and so it's 2 pi times 2, 4 pi. So that means that the graph of 3 sine x is stretched so that one cycle is completed in 4 pi radians. 4 pi radians. So how does that affect like our table? Okay. Remember our big 5, 0, pi over 2, pi, 3 pi over 2, and 2 pi. In order to apply your horizontal stretch or shrink by a factor of 1 over b, you essentially have to multiply your x values by 1 over b. Since b is 1/2, I have to multiply all of my x's by 1 over 1/2, which is the same thing as saying what? 2. So in order to apply that horizontal stretch by a factor of 2, I have to multiply all of my x values by 2. So that becomes 0, pi, 2 pi, 3 pi, and 4 pi. Those now become the new x values that I'm going to plot. Did everybody catch that?
Yes, ma'am.
Okay. My y values, because I'm trying to graph the actual full graph here. How does that 3 affect my y's? Exactly. So that's going to give me 0, 3, 0, -3, and 0. So these are the points that I am plotting to get 3 sine 1/2 x. So I'm at 0, 0 still, pi 3, 2 pi 0, 3 pi 3, and 4 pi 0. It completes 1 full cycle in 4 pi radians. Very lightly underneath the graph, you can see 2 cycles of regular sine x, but essentially you just have 1 period right here from 0 to 2 pi of the original sine graph. So as you can see, it has been stretched. If I look at example 9, it says sine of 2x. That 2 is on the inside. That 2 is your b value. So when it says to find the period, the formula to find the period was what I boxed on the last slide. What was the formula? So that's going to be 2 pi over 2, which is what? So my period is pi. It is going to complete 1 full cycle between 0 and pi. How do I get those values? Well, remember, you multiply it by 1 over b. So I'm going to multiply all my x values by 1/2, because b is 2. So I multiply all of my x values by 1/2. This is where you're going to need to know how to work with fractions here, okay? 0 times 1/2. Pi over 2 times 1/2. Remember, when we multiply fraction, we just multiply straight across. This one turns into? This one turns into? And this one. And if you do it right, before we apply any horizontal translations, their last value in your table should be the value of your period. Okay. So my y stayed the same. I didn't vertically stretch them or move them, did I? No. So there, pi over 4, think about your unit circle. Pi over 4 is halfway in between pi over 2 and 0. Pi over 2, 3 pi over 4 is halfway between pi over 2 and pi, and then pi. And because sine, just like cosine, they're sinusoidal functions, they're going to repeat the same cycle over and over again. So when it says how many cycles of the function are completed on 0 to 2 pi, how many full cycles am I going to have at the end of 2 pi? How many full cycles will I have? Yeah, I'm going to have 2, because I have 1 right now that goes from 0 to pi. So I'm going to have another one that continues the same pattern from pi to 2 pi. So I have a total of 2 cycles. Even without drawing it, I can know that because B also tells me the number of cycles I'm going to have between 0 and 2 pi. So I'll have 2 cycles. I'll have half a cycle. Does everybody see that? From 0 to 2 pi, it was only half of a cycle that was completed. So B also tells you your number of cycles. This one, it's not in your foldable. I just want to make sure that everybody has a good idea of how to go about applying the fact that we have a B value. Now, granted, this 3x is not in parentheses, but it is the number that's attached to your x. So you can assume that there are parentheses around my 3x. Okay? So, somebody online, tell me which coordinate is affected and how it's affected. So in other words, am I adding 3, multiplying by 3, dividing by 3, and which coordinate is being affected?
Both coordinates are being affected, both the x and y. Okay.
How is my x's being affected?
It's being, I know it's a horizontal translation or like stretch or shrink by 1/3.
Very good. It is a horizontal shrink by 1/3. Does that affect my x's or my y's?
That's your x's.
That's my x's. Am I going to add 1/3? Am I going to multiply by 1/3?
You will multiply.
Exactly. If you're able to describe the transformation, then all you have to do is apply that number to your coordinates. So I have to multiply all of my x coordinates by 1/3. 0 times 1/3 is 0. But what is 1/3 times pi/2? What's 1/3 times pi? What's 1/3 times 3 pi/2? Gotta know how to multiply fractions here. What's 1/3 times 2 pi? The period of this function is what? 2 pi/3. So remember, it's the formula 2 pi over the absolute value of b. So it's 2 pi/3. How many complete cycles will occur between 0 and 2 pi? 3. Remember, it's the value of b that'll tell you how many cycles will occur between 0 and 2 pi. Online, how are my y's affected?
They're multiplied by 3.
Very good. That's this 3 because they've been vertically stretched. So that's going to be 0, 3, 0, -3, 0. So when I graph this, I know this is pi/2. There are 3 angles in between 0 and pi/2. Think about your unit circle. That will help you in labeling. So I have 0, 0, pi/6, 3, pi/3, 0, pi/2, -3, and then 2 pi/3, 0. It is a very tight cycle, but remember, it's been horizontally shrunk. But I could fit 3 of those in between 0 and 2 pi. This is not in your foldable, so you might want to take a note of it somewhere. Okay? The horizontal transformations also affect the frequency of your function. Okay, frequency is the number of cycles a function completes in a 1 unit interval, 1 unit interval. Frequency is the reciprocal of the period. Okay, frequency is the reciprocal of the period. Smart notes here. So if you ever asked to find the frequency of a circular function, that's what these are, circular functions, sinusoidal functions, you'll basically do 1 over the period or the absolute value of b over 2 pi. It is the reciprocal of your period. That is how you find the frequency. Pi will be in the denominator once you flip it. A phase shift, okay? That is actually the official name of a horizontal translation when it deals with the sinusoidal function, okay? But essentially, like I said, it's the horizontal shift from the left endpoint. It is determined by the general equation above, and it equals negative C over B. Please make sure you emphasize the negative C over B, because I think that negative looks very small in the notes. In general, your formula for a sinusoidal function inside the parentheses is bx plus c. So you have to do the opposite of c and then divide it by b, okay? You're asked to find the phase shift of y equals 2 sine 3x minus pi in graph 1 of its cycles. The phase shift, again, is the formula negative c over b. So we have a negative c, negative pi, divided by b, which is 3. A negative and negative make a positive, so that's pi over 3. That means your graph is going to be shifted to the right pi over 3 units. Okay? Does everybody understand? To find phase shift, you do negative c over b when it's in the form of a sine bx plus c plus d. That affects your x coordinates. So you're either going to add the value or subtract the value if you're moving left or right. We're going to find the phase shift for y equals negative 3 sine the quantity x plus pi over 2 and graph 1 cycle of this function. Our phase shift is negative c over b. What's c in this problem?
Pi over 2.
So it's going to be negative pi over 2 over b. What's b?
1.
1. So negative pi over 2 divided by 1 is just a negative pi over 2. So that means our graph is going to be shifted pi over 2 to the left. The reason why it's left is because the phase shift was a negative pi over 2. You can also look at the original function. Remember, it's always the opposite. Plus means left. So my x values, I am going to subtract pi over 2 from every single one to get that horizontal translation. So the original 5, the original big 5, I'm going to subtract pi over 2 from each of them to shift it to the left. Now this one's a pretty easy value. But remember, in order to subtract fractions from whole numbers, you need a what? Don't forget about that. So I'm going to start at negative pi over 2. The next one's going to be at 0. Then pi over 2, because this is the same thing as saying 2 pi over 2, you know, common denominator. Just like this one's the same thing as saying 4 pi over 2. So I can subtract them. This one's going to be 2 pi over 2, which is just pi. And then this one's going to be 3 pi over 2. So as we can see, it's been shifted to the left. How are my y's affected?
Multiplied by -3.
So then that's going to be 0, -3, 0, +3, 0. The graph has been reflected over which axis? Somebody online?
The x.
Over my x, very good. And as we can see, I think this is off label. Nope, should be there. There's my graph of sine after it's been reflected, stretched, and shifted. What's the period of this function?
2 pi.
2 pi. Because b is 1, so 2 pi over 1 is just 2 pi. What's the frequency of this function?
1 over 2 pi.
Exactly. Very good. Now for your endpoints, this really and truly is more so just to kind of help you in the graphing aspect if you are having difficulty with the horizontal shifting. You can always find the endpoints of one cycle. Normally the endpoints occur between 0 and 2 pi. But once you incorporate all of this horizontal transformation, essentially what you can do is you can add pi to every side to get pi is less than or equal to 3x, which is less than or equal to pi, and then divide everything by 3. And then that will give you your starting point and your ending point for the cycle that you're gonna graph. Okay? Essentially take whatever's inside the parentheses, put it in between 0 and 2 pi, our normal endpoints, and then essentially solve for x, compound inequality. What was the phase shift of this problem?
Pi over 3.
Very good. It's negative c over b. So that's negative pi over 3. 2 negatives make a positive, so it's pi over 3. The graph moves to the right, pi over 3 units, and we can see that from the graph. What's the period of this function?
2 pi over 3.
It's 2 pi over 3. Very good. Find the endpoints of one cycle, okay? And then we're going to sketch this graph. So remember, normally the cycles start where and end where?
At 0.
Very good. But now with this 1/2 x plus pi over 2, we have to kind of take that into account. So we can just solve this compound inequality. Whatever's inside the parentheses goes in between the inequalities. So we're going to subtract pi over 2 from each side. So it's going to give me a negative pi over 2. It's less than or equal to 1/2 x, which is less than or equal to what's 2 pi minus pi over 2?
Is it 3 pi over 2?
Very good. And then how do I get rid of that 1/2? What'd you say?
Multiply by 2, really.
Multiply everything by 2. So when I do that, I'm going to start at negative pi and I'm going to end at 3 pi. That is my left endpoint and this is my right endpoint. How does that happen? Well, there's a few things happening to the x's. Okay? Let's start with my period first. What's the formula to find my period?
2 pi over 2. Determine absolute value.
And b is what in this problem?
1/2.
1/2. What's 2 pi divided by 1/2? 4 pi. So it's been stretched. That's why it spans a whole 4 pi radians from negative pi to 3 pi. That's 4 pi radians. But not only that, it's been shifted as well. To find my phase shift, it's the formula negative c over b. What's c in this problem?
Negative pi, or pi would be pi over 2.
And b is?
1/2.
So if I keep, change, flip, what is my phase shift? Negative pi. That means I'm moving to the left or right?
Left.
Left pi units. If it's a negative value, that means we're moving to the left. Also, take a look at the inside, and minus means we are moving the opposite direction to the left. So that's why the left endpoint's at negative pi, and then the period is 4 pi. That's why we go all the way up to 3 pi. Now, granted, the problem didn't ask me for all of this. It asked me for the endpoints, which we got, and to sketch it. So, but I just want to make sure you guys understood that. So I have to multiply all of my x values by 1 over b. What's 1 over 1/2? 2. To apply my phase shift, I'm going to either add or subtract it. So since my phase shift was negative pi, I'm going to subtract my phase shift. So I'm either going to add or subtract my phase shift after I multiply my x values by 1 over b. That's how you get the new coordinates of your x.
And the 1 over b came from, what formula would that be?
Remember, anytime we do a horizontal stretch or shrink, it's always 1 over that value. And so that's exactly how we apply it. So when I multiply everything by 2, these are the values that I get. But then when I apply my phase shift, I subtract pi from each one of them. So then it's going to be negative pi, 0, pi, 2 pi, and 3 pi. Those are going to be my new x values. Make sure that you write this down. You take your x's, multiply them by 1 over b, and either add or subtract your phase shift. Y's are pretty straightforward. I'm going to multiply by my a value and either add or subtract my d. I'm going to multiply all of my y's by what number?
-2.
-2. Everything is, we're building up to everything all together. So that's going to be -2. Nope. 0, because I'm multiplying. -2, 0, +2, and 0. So then these will give me all the points that I need to graph. And as you can see, I started negative pi and I ended 3 pi with a period of 4 pi radians. Questions?
Ms. Anderson,
Yes.
would you recommend doing the endpoints first?
Yeah. I didn't start with those because I kind of was already like on a roll and I was like, ooh, but I'll do them at the end to check. But yes, that's a good way to make sure you're starting at the right point and you're adding and subtracting is on point too when you do your phase shift.
I have another question.
Yep.
So how is it again that you calculate frequency?
Frequency is just the reciprocal of your period. So, yep, just do the absolute value of b over 2 pi. So if you find your period first, you just flip it for your frequency. So everybody got it? It's a lot once you put it all together. Leave that up for a second, make sure everybody's good. And then we'll do one more.
Ms. Anderson?
Yeah.
Ali asked in the chat, does it still make a difference for the x value if it is on the outside?
You mean like how we affect the x's? No, we'll still affect the x's by multiplying by 1 over b and adding or subtracting our phase shift.
So it only affects the phase shift.
So it only affects, yes, the phase shift. Yeah.
Do we always apply the 1 over b for the x values or no?
Yes,
Always?
always.
Okay.
All right. And let's look at a
slight doozy one.
Everyone should be finding out those values.
Ms. Anderson,
Mhm.
what was the formula for period again?
2 pi over b.
Thank you.
Ready?
Yes, ma'am.
Post y'all's homework. See how we did. Oh, I am still recording. Oh, snap, there's a lot dead there. Okay, well, there we go. So, I'm taking my original X values. That's gonna change. Until after I apply these different types of transformations. I'm gonna multiply them by 2 and then subtract pi over 2 from them. Somebody online, what values did you get?
For the x's,
Yes.
first I got negative pi over 2, and then I got pi over 2, and then I got 3 pi over 2, and then I got 5 pi over 2, and then 7 pi over 2.
Confirm?
That's what I got.
All right. Another way I'm going to confirm is to double check. I'm going to put those inside pieces inside of my normal period, my normal starting and ending points to see if I get the same thing. If I subtract pi over 4 to both sides, this will give me 7 pi over 4 here. Then if I multiply everything by 2, that gives me a negative pi over 2. And over here, this gives me a positive 7 pi over 2. So yes, I have the same starting and ending point that she has. And, you know, and the middle pieces actually go in a pattern. I go 1, 3, 5, then 7. Very good. Now my y values for cosine actually start how? With a 1. Then but since I add 1 to every single one of these, my answer is actually going to be 2, 1, 0, 1, 2. Y's are easy. It's the x's that I'm really more concerned about. When you make the graphs yourself, you can label your axes however you want to. And to be honest, this is the easiest. So like in your homework, when you have to do this, you can do exactly what I just did, which was take my blank axes and label it how I want to. Okay. So for the first 4, I do give you a graph for, but I think the intervals are similar to what's already on the graph. But then the ones that are a little bit more involved, you make your own scale. And then there you go. If you have your table there, I can definitely check to make sure that you guys got the correct answers as well. But this is how you find all the different features of a sinusoidal function and how you graph it. Nice little summary of everything that we've talked about today, okay, and the other day. Oh, we talked about midline last class. Remember, that's that point that divides your graph in half, and it's actually where your vertical shift lies. So y equals d is always the equation of your midline. It's the same thing as your vertical shift. Your period is found by doing 2 pi over b. Your frequency is the reciprocal of that. Phase shift is negative c over b if the b is on the inside of the function. Otherwise, it's just the actual c value itself. And essentially, this is a summary of all the concepts that we've talked about so far. We are going to be practicing some more on Friday because I don't see you guys again until Friday. But we're also going to be talking about writing equations as well.